All right, we're looking at the audio immersion assignment 1.4. This is frequency and amplitude. We're going to be doing this in two parts. We're going to look first at a session with sine waves, and then we're going to look at a session with actual music in it. And then we're going to talk about the frequency versus the amplitude. So, quick reminder, hopefully you caught on that the frequency is the number of completed waveform cycles per second. So if we measure those from zero crossing to zero crossing, so 0 to 0, there's one wave there, and it's about how many happen per second gives us what our frequency is. Well, the important part about that is when we talk frequency, we're talking about a horizontal axis. So we're thinking the horizontal is our frequency when we look at the waveform. And the vertical that we see up and down is our dynamic. So this up and down, highest peak, lowest trough, these are our volumes or our amplitude that we're looking at. And the amplitude is telling us how loud these actual waveforms have been recorded. And so if we look at them from here, what I'm going to do is I'm actually going to switch my counter so that it's at minutes and seconds. And if I go and start at the very beginning, what I can do is I can tell it to give me a length, a highlighted length of 1 second. I'm just going to type in 0, 1. And what it's going to do is it's going to highlight a 1 second section. So notice how many waves are there, how many cycles per second. And it's looping right now, so obviously it's playing longer than that. But you can see how many there are in that instance, and this is a 100 hertz tone. If we go back and we zoom into the high frequencies and we go check that out over here, let's go to this 18K section here, and let's again do the same thing. We're gonna give it 1 second, and we're gonna zoom into that 1 second and see what we see. Now we have to go very far. Notice how many cycles we see completed here compared to the other one. So many happening in just 1 second. Actually, way too many. I have to zoom out to kind of even fit it all in here, but you can't actually see the individual waves. Once we get zoomed out like there's thousands of them, literally up and down, up and down, up and down. In order to just hit that 1 second, so when we go listen to that, it's pretty quick, but you kind of see that 18,000 hertz, it has so many more completed cycles per second for the frequency. But the other thing is you also notice they're all at the same, for the most part, they're all at the same amplitude. So I'm going to shrink these up. Actually, let's get them to something that we can see all of them at once and then zoom out. What I have set up here is in this session, the audio, the sine, these are pure sine waves. So they are a pure wave, the purest form of the wave. They're going to be emitting frequencies from these stages: 100 hertz, 500 hertz, 1 kilohertz, which is 1000 hertz, 5000 hertz or 5 kilohertz, 10,000 hertz, 15, 16, 17, and 18. And you notice I only did a few low in the list. So these are the lower frequencies. So like that 100 is getting very near the sub frequency. And then we're in the low mids with 500. And then 1K is the mid, 5K is the high mid, and then 10K is the highs in terms of frequency range. But then I included a bunch 15, 16, 17, and 18. And there's a reason that I did that. The reason is when we get to 15 and we start to hear it go up, the one thing that I want you to do is I want you to listen to see at what point you stop hearing the higher frequencies. Excuse me, what happens is your hair follicles inside of your inner ear that transmit from the eardrum to the actual neurons in the brain tend to die off. And when they die off, we actually lose hearing in the upper frequencies, the higher frequencies. So as you age, you actually lose the ability to hear some of these higher frequencies. So for me, as an example, I can't hear 18K, but I can hear 17. I have students that can hear all the way up, and I have some students that only hear 15. So when you're listening to this, you're just listening to see how far can you hear, because it is actually going to be playing. So let's start at the beginning, and let's have you listen to these tones. Here we go. All right. So again, I'm curious how far you heard, but you should have noticed a difference. One of the things as we travel from the lower to the middle up to the top is that the tones tend to be the lower frequency tones tend to resonate like the walls, or they resonate your body. They really get that resonance going, and as it moves up higher, it gets very focused. And once we get into that really high frequency above 10K, as we get into the 15s and above, it kind of gets piercing. It's like in your temple, and so it does get a bit sharp. So just understanding that is very important because that'll help you dictate the frequencies you have to actually go reach for when you're working with your audio. You're listening to something that's wrong. Where is it at? Is it in the subs, low mids, the high mids, or the highs? You have to be able to figure that out. You have to be able to decipher that in real time when you're actually working with a source. One more time, just to give you the opportunity to test this out, I'm going to start at the 10K and I'm going to let it go up to the range, and you follow which ones you're hearing. Here we go. There's 10K. Here we go to 15. And there it is. All right, we're going to move on to our other session because I want to talk a little bit about one more session here as we kind of talk through these kinds of things. Let me open it up real quickly. Okay, this session's called Force Blues. It's real basic. This one is just a beat and four layers of guitar. There's really two sections of guitar that are happening, and a beat that goes underneath it. We'll start it from the beginning, but notice this is where you start to answer the questions that are in the frequency and amplitude question element. It asks about which of these tracks are higher in frequency, lower in frequency, how you describe them in terms of volume. You can see their volume overall and some of their frequency elements, but these are complex waves. So unlike the sine wave, you're not going to see like just a standard traditional full completion. What you're going to see instead is when you zoom into these waves, you will see what we call a complex wave, which is what happens when you add up different frequencies inside a wave. Notice it just doesn't go up and then down and then up and then down. That's it. Notice all these peaks and these valleys in the middle, in the transition. This is what happens when those frequencies are trying to make their cycles per second on top of each other. So remembering that lower frequencies have further spaced apart waves, or like completion for their waves. So they're going to be longer in terms of it. Like it's going to take them longer to complete one cycle. The smaller ones are higher frequencies. So like higher frequencies are going to have very small rates of frequency cycle completion. And so that's why when they collide, they add up, but they sum up to look like this. So this is what we know as a complex wave. Let's go take a listen to this song, and then we're going to break down a little bit of it so you can answer some of these questions. All right, yeah. So we kind of get an idea of what's going on in here. So a couple things we want to look at is which ones are in the higher frequency range, which ones are in the lower. I think if you look at the drums, let's start here. You can kind of get a sense of what's going on here. And actually, to make this job easy, what I'm going to do is I'm going to bring out an EQ that has a real time analyzer, and what that is it shows us what frequencies are actually being emitted from the track. So this is actually going to be on the overall track. So use your ears, of course. I think hopefully by now you notice that in that drum part, the kick is low, the snare is high, but watch them as they go through this device. Just to clarify, though, on this EQ, you can see a frequency spectrum that starts at 16 hertz. Notice it goes up to 32, 63, 125. It shows you all these bands. These are all the sub frequencies, low mids, mids, high mids, and then highs. And here we go again. You can listen to that. So notice it's not that the kick actually has a low presence, but it's not that the kick has no is void of highs. It still has high frequencies. I'm actually just going to mute this real quick so you can listen to that, or you can watch it go by as it's going through, and as I talk about that. So notice the kick still has these high frequencies as it's playing. So again, going back to the kick drum, it still has high frequencies, but the focus, the amplitude strength, meaning the volume strength is here. The snare's volume strength is over here in the mids. There's one particular peak every time that snare hits, just above 500. Snare drums typically love 600 to 800. That's like their strike range. That's really usually that's where they ring out pretty true. But let's go back to this. Let's take another look at some other things. Okay, so kick snare, that makes sense. Let's go look at the guitars. There's things happening with the guitars. I'm going to solo them and bring them into focus so you can hear them, and then I'll bring this back in a second. Now I'm going to wide pan these so that they're very transparent. You should hear a left and a right. Let's try it. Now, if you have your headphones on correctly, meaning on the right side, you should notice that on the right side we have the high guitar. This is what we're hearing up high. And on the left side, we have the low guitar. Now again, I'm going to bring out the RTA so you can see it. What's happening with the tone between those two. So again, I'm going to stay with the left. The left is the lower guitar. Here it goes. So something actually pretty wild and fantastic. Frequency is equivalent to pitch. So every pitch that you sing, every pitch that you play has a specific frequency that it actually emits. And so as the guitar is changing chords and it's moving downward, you're actually going to see on the RTA the frequencies slide this way, the focus. So watch, you'll see it again on that. On this is a low one. If you watch that white line, there's a white line coming through. You'll see it again. One more time. And let's go to the high one on the right side. Fantastic. Let's go to one more guitar part and then take a look at that. So in the next section that follows, it's almost the same thing. You're going to hear octaves being played. You're going to hear the octaves shift around. I'm also going to hard pan those so you can get a sense of that. This is them together without the hard panning, and then I'll hard pan it about halfway through. Okay, so the beauty of this is if we go to just this one, the one that says lead guitar 2, it will be on your left. Listen to it by itself. Is it high or is it low? All right, and then let's go to the one on the right. Is it high or is it low? And now what I'm going to do is I'm actually going to, this time, instead of bringing out just one RTA, I'm going to bring out two. And this will give you the opportunity to analyze this for yourself. I'm going to open them both up. This is the one that you're going to hear on the left. I'm going to have both of them playing at the same time. And this is the one that you're going to hear on the right. Okay, so you should be seeing two different sets of analysis, one on the left and one on the right. Let's take a look. Now this is a little tough because the low one actually has some particular EQ spectrum elements up that are real strong up here. So let's go find the fundamentals. What I'm going to do is I'm going to add a bandpass. This is something you don't have to do, but I want you to see it just so that you understand what we're looking at when we're talking about these. I'm going to add this bandpass and I'm going to slide into these fundamental areas to try to find where is that focus point for this guitar on the right. Okay, about found it. It's right there. Let's go find the one on the left, which should be the higher one. I'm going to activate these as well. Just bring those cues up. I'd imagine it's going to be somewhere up high. So like as we're moving this, I'm just adjusting the slope. I'm putting a high pass and a low pass activated together, which make a band pass. It should be expected that it should be lower than the previous one that we saw, or higher than the previous one that we saw. So here's the issue. The issue with it is this, that in order to have an octave, so these are being played an octave apart. In frequency, because frequency is equivalent to pitch, when I sing an octave note up, what I'm actually doing is doubling the frequency. And this is where it starts to get interesting. Down low, when we're looking at parts that were down low or lower, you'll notice that if I were to pick out a frequency at 100 hertz, okay, so let's say I pick this number 2 and I set it to 100. Oops. Its position is there. If I take number 3 and take it up one octave, what's one octave up from 100? It's just double 100. 100 times 2 is 200. Look at the spacing, okay? Now what I want you to do then is, and I'm going to deactivate 1 so you don't see it. So we're focused on 2 and 3. And then let's go to 4 and 5. When you get to the higher frequencies, about where we're focused now, so if I say, all right, well, let's say our center focus is about here, at about, well, we'll call it 2800, or 2800 essentially there. And then we go to 5. What's one octave up from 2800? And this is where, like, in this piece, you basically have to be mindful of the fact that because we're in the higher frequency band, we have to specifically pinpoint higher frequencies that might actually be closer together. So that duplicate is 5600. And I want you to notice something here. Let's go look at this. So let's say this is the center, and what we called 5600 the other octave, or the octave up. I'm going to set them more on 4. And then in this one, what I'm going to do is I'm going to set this one's number 5 at 56. And I'm going to then take this focal point. Oh, I'm sorry. Did I do that backwards? Oh, shoot, I did do that backwards. Okay, I'm so sorry. This one's the high. Forgetting that this one's the high, what I really needed to do is half 2800, sorry, because this is the higher one. So I need to go one down, I'm sorry. So going one down, I should be looking for 1400. I'm going to take, again, I'm going to take number 5 to 1400. Hold on, let's see it. Oh, I can take number 4. And this should be about my center point. There it is. So when I'm listening to these guys play an octave from each other, this is what we should be hearing here. Awesome. So you're gonna make sure you answer your questions for these for this immersion section, and just keep in mind like which tracks are which. Again, this one had drums, lead guitar 2, lead guitar low, rhythm guitar, and rhythm guitar high. That's how they were labeled. So, all right.